period of time at the end of last season where the Mets and the Rangers were doing extraordinarily well at the same time.
Not anymore.
Not anymore. Not anymore. And also in the beginning of the season for football, the Giants were doing great, and not anymore. Yeah, and, just kind of we're on the downswing now. I want to get back, at least into a non-depressing state. Although I did stay up to 2 o'clock in the morning to watch the Rangers Sharks.
They're doing that bad.
Yeah,
They have a playoff spot.
yeah, they're average at this point. Yeah. But that game was so boring until the last 5 minutes, in which case it was so compelling.
I love those games.
It was like 0-0 midway through the third period. Rangers score, break the ice, then get an empty netter. Up 2-0, cruise control. Sharks immediately score on them, and now it's like a nail biter the rest of the way. I couldn't go to sleep till like 3 o'clock in the morning because I was so amped up. Rangers, what are you doing to me? So we're gonna create the scatter plot, insert chart. Hopefully it reads your mind. All right, population versus, it looks like it did everything I would want it to do. It labeled everything nicely. It looks like a linear relationship, but you could also make a case that because there's a little wobble there, it could be polynomial. All right. But what we do is we go to the three dots, or you stay in the editor. Under customize, I mean, you got all the different things. If you needed to adjust the title and stuff like that, that's fine. If you go into series, whenever they talk about series, they're just talking about how you want the system to evaluate the series of data that you typed in. All right. But if you go down the line here, I mean, you can change font size and stuff like that. You'll see one that says trend line. Select that. It'll plot the line. But if you go further, you see we have under label, use equation. So it'll put the equation there for you, all right, so that you don't have to compute it. I also like to enable R squared. We talk about correlation coefficient a lot, the R value, but R squared is the coefficient of determination, which is, I mentioned this last week, but it was a while ago. I call it the lockstepedness between two variables. All right, what's the percent of change in one variable when the other variable changes? All right, is it 100%, as in they're in lockstep, or is it close to it? In this case, it's pretty close. All right, so the R squared is the coefficient of determination. So I'll just pop that in here. That's 0.977. And then we have the abbreviation LSRL, least squares regression line. Let me do a merge here. That's going to be y equals negative point. Well, we like to have the constant value first. So we're going to say 1173 minus, put a little space up. Command Z. Minus 0.587x. All right, so that's my least squares regression line. What I want to do is use that model to figure out what the residuals are going to be, and then from there come up with a residual plot. All right. We could also make the prediction. We did the scatter plot. We came up with the LSRL. Predict the number of people living on farms in 2025. So that's what we call extrapolating. Right? But prediction methods, they boil down the same way, where it's you have that line. Now use that to predict something that's way off in the future. All right. So if I came up with a linear regression equation to represent the height of a human being, and then made a prediction of what the height of the individual will be at the age of 45, it's probably going to be pretty severe. All right. In this case, we're talking about population in thousands on farms. So what we would do here is we take the 1173 minus 0.587 times this particular X value. All right. So this is saying that in 2025, there's going to be negative around 15, 16,000 people living on farms. All right. Doesn't seem to make much sense. All right. Population cannot be negative. So this number is not valid. Just like randomly striking keys and hoping it makes a word. All right, so this number is not valid. All right, there will come a point in time if you're dealing with a negative linear equation where it'll hit zero and it'll go negative. You just got to ask yourself, does that make sense? All right. If we're talking about a positive population, that works. You could expect to have a positive number of people living on a farm, but a negative one, like I don't even know how to conceptualize that. That wouldn't make sense. It's like, how do you have a negative person? It's like mirror universe, I guess. I don't know, but not valid, definitely. All right, but I want to apply this idea to all of the years. All right, and so that's going to give me, and we could do the residual all in one shot. I broke it apart last time just to kind of give you the sense of the bits and pieces. But if I'm taking my Y value and subtracting from it the Y hat or the predicted value, well, why not do that all in one shot? All right, so I'm going to take this Y value, which is at B3. I'm going to subtract from it whatever I would get if I plugged my X value into the linear equation. So 1173 minus 0.587 times my A value. When I hit enter, it's going to lock it in. I don't need dollar signs. Take the suggestion. Now I have a residual plot, which is great and useful. I'm sorry, I have a residual column. I want to make a plot out of it. All right, so I'm going to take this stuff here, bring it down, edit, paste values only. I'm going to get rid of the population column, delete cells, and shift left. All right. And then I'm just going to make a scatter plot out of this information. So insert, chart. It assumes scatter, which is great. I don't need a trend line in there. This is all I need to determine whether the approach I used was valid. All right. So the residual plot, I'm not really seeing a pattern there. I mean, maybe there is, but if you have to get inventive in order to see a pattern, then there's no pattern. Right? It's just one of those things like, what's your first impression, pattern or no pattern, and then go with that. Because if you stare at something long enough, I mean, I'm looking at it now, and I'm seeing the Big Dipper. Yeah, I got the little box over here, and then that little tail. I was like, okay, great. I had to go to my list of constellations in order to come up with a pattern there. I'm going to go ahead and say that there's really no pattern there. I mean, if you see a parabola, you see a natural log function or a line, those are the obvious things. All right, so there is no pattern to the residual plot, which tells us, so I'll say therefore, a linear model is appropriate. All right, no pattern to the residual plot, linear model is appropriate. If you want to play it safe, just couch your response a little bit. I don't see a pattern in the residual plot. All right, I can't mark that wrong because it's a question of what you saw. I see something different, but you said you looked at it and this is what you determined. I don't see a pattern. Then there's no pattern. All right, but the key takeaway, I guess, is that no pattern in the residual plot means that the linear model is appropriate. All right. Up here, what we did was we took a line and fit it to the data, which is great. But maybe we should have used a quartic function or a natural log. All right. We did the work. We came up with a line. We don't know if that's a valid approach to use until we come up with the residual plot. So that validates everything that we did up here. All right. So our predictive value is as correct as it could be with a negative linear function. Is it a reasonable result? We already addressed that. And so that's all there is to it. All right.